Hello children, welcome to channel Sube. Children, today I am going to discuss question number 32 from the MCQ part of 2021 Physics New Syllabus paper. Three capacitors, each of capacitance capital C, are connected to a battery and a key capital K. This one as shown in the figure. Initially the key K is closed. Initially this one is closed like this. Once the capacitors are fully charged, the key K is opened. If the potential difference across the battery is V, the total charge of the capacitors in the circuit is first one not changed, second one decreased by 1/3 CV, 3 decreased by CV, increased by 1/3 CV, increased by CV. So children, let us try to solve this problem. First of all, I have to take a copy to discuss, because they say at the beginning this switch is closed. So let us close it like this. Now the switch is closed. So at the beginning, that is the condition. So let us take some room here, because I have to write things here. So I adjust a little bit like this. So the capacitance not change, just for explanation I took some room here. So first this switch is closed like this, so the connection is there like this. So I can draw, say this one is negative, this one is positive. You can see it because the longer line is they have drawn to the left. So this negative wire from the battery is connected like this, continuously. The negative wire is up to this place, and here also it is supplied to these capacitors at the beginning, and the red wire from the battery is only going like this, is connected only to this plate. So therefore this capacitor has received both the positive and negative wires. To be charged, a capacitor must receive the both positive and negative wires from the battery, otherwise it will not get charged. So therefore no problem, this capacitor get charged like this, because both the negative and positive supplies there to this capacitor. So there is no drop along this line. There are no any other devices, any other components connected. So therefore the total this voltage V appears here. That means this capacitor charge up to V voltage, to a voltage equal to V. So then you can see these capacitors have not connected to the battery positive, only both sides are connected to the battery negative, then they can't get charged. So you know, if this one is a battery, so if this one is the capacitor, normally a capacitor you look like, if you buy a capacitor from a electronic spare part, electronic component shop, the capacitor looks like this. It's a sort of cylinder, small. So there are two terminals like this. One is called negative like this, the other is positive. So the positive side of the capacitor you must connect. So imagine that these are the terminals, the legs. So the positive pin you must connect to the positive side of the battery. This one is the positive side. Then the negative negative pin of the capacitor must be connected to the negative side of the battery, then only the capacitor gets charged. If you connected like in that figure, that means if you connected it like this, if you connected it like this wire is not used there, so they have connected like this. Will it get charged? No, it won't get charged, because the positive wire must be connected to the positive side of the battery, but they have not connected it like that. Both the wires are connected to the battery negative. Here you see, for these capacitors, the supply is taken only from the negative side. Negative side goes to this terminal, and also negative side connected to this side also. So the capacitors, these two capacitors, therefore won't get charged. So therefore the total charge is only something here, say Q. So after that, what they do is, let us take a copy. Let us take a copy to here. So after that, what they do, they open this switch. They open this switch. So what happens? Now the switch is open like this. So then you can't see this battery connection. Up to this level the connection is available. This connection is still available up to this level, but this connection vanish. This connection no longer you can see, because the switch is opened. So there is no negative connection to this side as previously, like this. But now already this plate is negatively charged to V voltage. So that connection is still here like this. That negative plate is connected to the left plate of these both capacitors. So up to this level that negative voltage is there. So like this, and also this negative voltage up to this level is there. So what has happened? Nothing wrong, nothing wrong, nothing changed. Nothing changed. The diagram is equal to the previous one, you see. The negative voltage is everywhere as it is in the first diagram, only this switch is opened but nothing has happened. You see, this one, this region, everywhere the negative wire is connected, negative voltage is there. And also here the negative voltage is everywhere, because from the battery the negative voltage is here up to this right side plate, and also to this right side plate, and also to the right side terminal of this key. And from this capacitor the negative voltage is there along this line to the left side plate, and also to the left side plate of this second capacitor, and also to the left side terminal of this key. Negative voltage is there. So even though we put off the switch, nothing has happened. The voltage has not changed anywhere. The red wire is there as it is still, so the positive charge is there still. So therefore nothing changed. Therefore the charge remains constant. So the answer is therefore this one, not changed. The charge doesn't change. So the answer 32 first one. So correct. Then there is another method we can describe what happens like this. So the second method is like this. So again let us get some room here. I am doing this without pausing the video because you can then understand, otherwise you will not know what are the changes I did. So as previously, this condenser, this capacitor get charged like this, as I explained. Since this switch is closed, first they said that it is closed, so the switch is closed. Now no problem, the negative wire is connected like this through this switch to the right side of this first capacitor, the plate of this first capacitor, right side plate. So the positive voltage comes up to this place and it is charged positively. The negative wire also somehow connected to this right side plate through this key, so it is charged negatively like this. So the voltage V, this voltage must be here, this condenser get charged to our V voltage, up to V voltage, because there is no drop here along this line, and also there is no voltage drop here along this line because no components are connected either sides. So the totally V voltage is being supplied to this condenser, and so it is charged up to volt V. So there is a certain charge given by Q equals CV. So however, that is the condition. So now I am going to decrease the length of this wire. So there is a long wire like this. I am going to decrease that the length of that wire and take this condenser closer to this battery now. So I don't change any change in the structure, only I am decreasing the length of this wire. So this condenser now comes closer to this one, but remember, positive to positive, the connection was previously positive to positive, that you have to notice, otherwise you will not understand. Positive to positive. So when I reduce the length of this wire, I have to connect it correctly so that the polarity is not changed. So therefore I have to rotate this so that positive to positive connection is obtained. So like this, positive to positive, because when I drag it here I have to rotate it a little bit. You can understand, I think, because otherwise you can't connect it without changing the structure. So now I connected it like that. Then this wire normally goes to this junction. Now what I did, I dragged this condenser where it was here previously, and now closer to this battery. So no structural change I did, just I drag this condenser to closer to this one. So let us do little more. So Q upside down, right. So like this. So V voltage also must be there, V voltage. So now after getting that condenser charged, what they do, they open this switch. So let us now again check what are the changes has happened. So they open this switch like this. Now there is no connection between these two lines, but still this negative wire is connected like this up to this point. So here it is connected still to these condensers like this, same as previous, you can say. And also this negative side has negative voltage as it is in this battery. So this negative wire connected is still to this one, like this. Negative voltage is here up to this place, to this plate. So now so this condenser, which is already charged, behaves like a battery, because it is charged. The charge can't go anywhere because no connections, therefore the charge is here still, so it is connected like that. So to charge this condensers, so let us isolate these condensers like this. So this wire we don't want now because it is opened. This wire we don't want now, it is useless because switch is opened, there is no connection. To consider the wire, there should be a connection. If there is no connection, wire is useless. So therefore we remove that wire. Now the condition is like this. So if you want to charge these condensers, what you have to do? You have to connect the red wire from the battery, blue wire from the negative side of the battery. Then only these condensers get charged. But what has happened here? Only the blue wires are connected. That is one thing. So therefore this area doesn't get charged. And also since this one acts as a battery, we can draw that this side is positive. We can draw a battery. We can replace a battery instead of this condenser. This side positive, so the longer line of the symbol, so the shorter line, this side negative. So a battery is connected like this, this side negative, so the wire negative wire is connected like this, this side positive, and that battery is connected to the original battery which was here previously, from the previously itself. So this battery is what we had at the beginning. So then so the voltage is V. This one also has a voltage V. Both has now voltages V. So this negative terminal is this one. So we can now delete this one because we have drawn equivalent components. The battery, same battery, but this instead of this condenser, charged condenser, we have drawn a battery, same polarities, positive this side, positive this side, negative this side. So negative this side, voltage also V. We have replaced a battery instead of a condenser, charged condenser. We can do it. If the condenser is charged fully up to V voltage, we can replace a battery instead of that. So now we can delete this one. We don't want this one because we have replaced another one. So this battery also we don't want. So now what has happened? So these two are opposite to each other. These two batteries are opposite to each other, positive, positive. Positive, positive are connected together. So you know, when these batteries are connected like this, the equivalent voltage is 0. 0 because V, same magnitude. The directions are opposite. So therefore final voltage of the supply is 0. Therefore these condensers don't get any voltage. So we can write something like this. Therefore this battery voltage is now 0. So this one doesn't get any charge. So therefore the charge doesn't change because these condensers don't get extra charge. So therefore the answer is again not changed. So I explain now two methods, using two methods. What is the resultant voltage using the theory of resultant electromotive force, resultant EMF. Resultant EMF is 0 here because VV, we have taken the EMF as V, or we can use E, whatever it is, doesn't matter, E or V, both are symbols just, but the direction is opposite, the magnitude is equal, therefore resultant equivalent voltage is 0 finally. So using that method I explained it that these condensers don't get any charge at the second time when this switch is opened, and also I explained using this wiring methods that these condensers don't get the positive wire from the positive terminal of the battery, therefore these condensers don't get any charge after switch is closed. So in both ways I explained, this answer is the correct one, first one. So let us check 32, the first one is correct for 32. So children, I think you understand that it is not a very difficult one. So I explained so that you can understand using colors. So I think you are happy. So children, I think you are happy. If you are happy, please make me happy also by subscribing my channel, but only if you haven't still subscribed. If you have already subscribed, don't subscribe again, don't subscribe twice, then it will be cancelled. So see you tomorrow guys, goodbye.